The intent of this video is to explain the steps involved in converting the high-level scope into a detailed schedule, a step-by-step workflow analysis. This workflow is quite huge. We scope to schedule. There are two major aspects to this. The first one is the scope part of it. As projects progress, the scope gets elaborated. So we start with the high level scope at the initiation stage. Then during the planning stage, we get into requirements elicitation, requirements analysis, and then we come out with the scope document. And we decompose that scope document into a work breakdown structure, then work packages, WBS dictionaries. So along with the scope document and the WBS, it gets baselined as the scope baseline. So all those aspects we'll discuss under the header or under the branch scope. And once the scope is finalized, then the schedule preparation, at that stage, the schedule preparation starts. When I talk to many of my students, they are working as, some of them are working as project planners. And all they tell me is that, okay, see, they are working on MS project or Primavera, and they just enter the activity sequences into the tool. That is their job. But quite a lot of work need to be done prior to it. So how do we get these practical activity sequences? So there is quite a lot of work which calls for intergroup collaboration, interdisciplinary collaboration. So that is key. So at the end of watching this video, we will get clear step-by-step process of converting that high-level scope, which gets defined during the initiation. As part of the charter, we have the high-level scope, very high-level scope. That need to be elaborated further, and then that need to be decomposed and activity to the activity level before we sequence them. So that is the intent of this video. Let us take a closer look at the scope part of the mind map. During the initiation phase, which is the first phase of the project management lifecycle, where the sponsor and the probable project manager and with the key stakeholders, they kickstart the project. A formal start is given through project initiation. And during the initiation phase, we develop the project charter. And within the project charter, we have the high-level scope defined, which is never more than 1 or 2 paragraphs. So one of the key characteristics of the project itself is progressive elaboration nature. And within that, the classical example is the progressive elaboration nature of the scope. During the initiation, high-level scope, that is part of the project charter, and we identify, we come out with the stakeholder register itself. See, the output of initiation, we have project charter, which contains the high-level scope, the success criteria of the project, the major milestones with dates, etc., etc. And we have the stakeholder register as well. Then we get into scope definition part of it, which comes as part of the project planning. The first step here is develop a scope management plan. How are we going to develop the or detail the scope of this particular project? We need to have a plan for it. We need to have a RASI chart for it. Who will do what? What is the timeline for it? What is the budget for it? And what is the critical success criteria for the scope definition part? Who all must be involved? Uh, and what are the tools and techniques to be used? Sometimes we can use brainstorming, sometimes it can be one-to-one interviews, questionnaires, surveys, benchmarking. All these things are possible while defining the detailed scope. But here, the key thing is we need to engage the key stakeholders while defining the scope. So, for that, we need to have a scope management plan. Typically, a RASI chart. What is the team size required for it? Timelines. Who will do what are the validation processes involved, at what stage, and will we use any tools, and how it will be documented. And once it is finalized, how the changes to the scope will be managed. So there we need to define the change management process for scope, and who can approve uh, the scope document, and who must approve the changes, and who all will be part of the change control board for scope changes. Everything gets into the scope management plan. At this stage, I recollect one project I was part of. That was about the whole project itself was defining the scope for water authorities of all the states of India. So, a lot of logistics because we need to interact with the head of these authorities, and mostly they are top level IAS officers. Their time must be available, it must be scheduled. We need to travel. A lot of logistics had to be planned. So that gives me the insight on how important it is to have a scope management plan. Then we go and elicit requirements from the stakeholders. It could be through observation, it could be through interviews, it could be through questionnaires, surveys, prototyping, brainstorming, any tool we can use for requirement elicitation. We may use a combination of tools as well. And once we collect the requirements in detail, then we get into requirements analysis. One is requirements elicitation, then we analyze it, and then we crystallize on the scope document, which will contain what all things we will deliver and what all things will not be delivered as part of the project. And the acceptance criteria also can be part of the scope document. And once the scope document is finalized, the next step is decomposing the scope document into a work breakdown structure. It is a deliverable oriented grouping of project work. We have a separate video lesson on work breakdown structures. So, a WBS decomposes the scope document into a tree structure or a list structure. And we have thumb rules like 880 rule uh, that says that the scope must be decomposed to a level of 880. That means the lowest level in the WBS is the work package, and the work packages must be between 8 hours and 80 hours chunks of work. Smaller the project, the affinity of the work packages should be towards that 8 hours, and larger the project, the affinity should be towards that 80 hours. So 880 rule. Then we have this 100% rule. That is 100% of the scope documented in the scope document must be reflected in the work breakdown structure. If we miss out on something to capture in the WBS or the work breakdown structure, most probably that will not be there in the final set of deliverables. So 100% rule ensures that whatever we document in the scope document, that will be part of the work breakdown structure. And the work breakdown structure has multiple levels. It can be represented as a tree structure or a list structure. And the lowest level in the WBS we call as the work packages. And it is at the work package level where the budgets are determined. And in some cases, even the schedules are high level schedules are decided at the work package level. And here, another key thing that happens at the WBS level is the make or buy decisions. Once we know the work packages, then it is easy to decide what all work packages will be done by ourselves and what are all the work packages that will be delegated or outsourced or subcontracted. So make or buy analysis is a key thing at the work breakdown structure level. And these work packages are supported by WBS dictionaries. So a WBS dictionary provides more details about that particular work package, like the control account. What is a control account? What is the how much is the budget for that particular work package? What are all the successes and what are all the predecessors to that work package? And what are the quality standards that must be followed while performing that job, etc., etc. So all those things gets into the WBS dictionary. So at this level, we get maximum detailing of the scope at the work package level, along with the WBS dictionary, that gives sufficient details for a person to carry out that work right at the first time, every time. And once the scope document is clear, is approved, and the WBS is finalized, that becomes the scope baseline. So, what is the scope baseline? It is the scope document version 1.0, means any changes thereafter should undergo a change management process because we have to raise a change request, we have to do the impact analysis, and the change request can be either approved or rejected. And in both cases, the communication should go back to the originator of the change request. And if it gets incorporated, we have to do the impact analysis on cost as well as on schedule. And those impacted items also must be changed or updated. So once the scope baseline is done and if it is released for use, then the monitoring and controlling aspect of the scope starts. We have to ensure that the work is satisfying. The first thing is the scope is satisfying the contractual obligations. That is the first check. The second one is the execution is delivering stuff according to the defined scope. So we have to monitor and control that aspect. And throughout this monitoring and controlling, the change management process is active. So these are the steps involved in elaborating that high-level scope, which is part of the project charter, into a detailed scope document and into a detailed work breakdown structure to the level of work packages and WBS dictionaries. And at this stage, this becomes the input for uh, schedule development. Now we'll move on to schedule development. Now, first thing again, you have to create a develop schedule management plan, and the output is the schedule management plan. Why this is important? So in a project, there are multiple stakeholders. So if you take an EPC project, there is a contract, there is owner side is there, consultants could be there, contractors are there, subcontractors are there, suppliers are there. So every and quality assurance teams will be there, risk management teams will be there. So everybody need to prepare their own schedules. Here, the practical problem is which tool to be used. Will you use MS Project or will you use Primavera, or somebody may be using Excel sheet, somebody may be using some of the agile tools, or somebody may be using the scheduling tool within project management information systems like Ren Smart Project or Econix, or somebody may be using the project management module within the uh, ERP stuff like SAP, etc. So we need to standardize. Who will create the schedule? Which tool to be used? Who will approve the schedules? What are all the integration points across these schedules? Who will update this? Who will update the status information or progress information to the schedule? What will be the frequency of it? What will be the unit of measure of progress? All these must be defined. Otherwise, it'll become impossible to come out with the integrated project schedule. And without an integrated project schedule, the project managers and the project controllers will not have visibility into what is happening in the project. Now, as a best practice, sometimes in the tender document itself, people started mentioning that for this particular project, we'll be using these tools. So as a contractor, you must gear up for that. So that will become a contractual obligations so that this integrations becomes much easier. So this develop schedule management plan is very important aspect of project success. And once the schedule management plan is done, then we start with the schedule development work. Then we start with the activity definition. So in the previous stage, we start with the work breakdown structure. We have the work packages. Now it is time to decompose those work packages, which are the lowest level in the WBS. It is time to decompose those work packages into activities. And we come out with the activity list. So decompose the work packages into activities, and the output is the activity list. And next step is activity duration estimation. We know the activities now. We have to estimate the duration. For that, we use estimation techniques like analogous estimation, parametric estimation, and three-point estimates as well. Analogous means we compare. If there is a similar activity done in the past, we compare and take. That is analogous estimation. Parametric estimation, we have multiple data points. That means we have done a similar activities multiple times in the past. And that is available as historical data of projects. So then we can always leverage parametric. That is, you take an average of it. So parametric is always more accurate than analogous estimation. Then we have three-point estimates. That means for every activity, we come out with three numbers: optimistic, pessimistic, and the most likely numbers. Optimistic means the most aggressive estimate. Pessimistic means the most liberal or the worst scenario. Optimistic, the best scenario. And the most likely is most probable stuff. And we convert this three-point estimate into a single point estimate using the formula optimistic plus three times most likely, four times most likely plus pessimistic by six. And we have another formula as well, that is optimistic plus pessimistic plus most likely divided by 3. So those are explained in the project estimation video lessons. So the objective of this lesson is just to introduce you to the workflow, starting from scope definition to completion of the schedule. So we come out with the activity list and then we estimate the activity durations. Then we arrive at the activity sequencing. Sometimes after activity sequencing only we get into activity duration estimation. In this video lesson, I just try to explain activity duration estimation prior to activity sequencing. It could be the other way as well. Now, in activity sequencing, there are four types of dependencies between activities. Uh, they are finish to start, finish to finish, start to start, and start to finish. When we say finish to start, something must get over for me to start something else. So if I'm following a classical waterfall model, in software engineering, I may say the requirements definition must get over for me to start designing. And the designing must get over for me to start coding. And the coding must get over for me to start testing. That is in a traditional model, or which is the waterfall. So that is finish to start dependency. Something has to finish for me to start something else. Then finish to finish. Something must finish for me to finish something else. In construction, the flooring must get over for me to complete tiling work. I may start tiling work when the flooring is 30% completed, but I will not be able to complete the tiling unless and until the flooring is 100% completed. Something must finish for me to finish something else. Unless and until the coding is completed, I will not be able to complete testing. When I start coding, I may start with testing, but I will not be able to complete testing unless and until the coding gets completed. That is finish to finish. Start to start. When something starts, I can start the other one. When coding starts, I can start testing. When something starts, I can start something else. Then start to finish. When something starts, I can finish something else. When the main power supply comes in, I can stop the generator. But 80 percentage or 80 to 90 percentage of the occurrences in scheduling will be most of the things will be finished to start, followed by finish to finish and start to start. But start to finish is very rare. So by applying these constraints, finish to start, finish to finish, start to start, and start to finish, on the activity list, we get the activity sequencing. This is not that easy, okay? Because multiple trades are involved in projects. If we take an EPC project, there will be civil work is there, electrical work is there, architectural work is there, HVAC related work is there. So multiple disciplines. It's not done by one team. And there could be interdependencies between multiple disciplines. For example, while doing the foundation work itself, we may have to provide for drainage and sometimes ducts for HVAC, etc. So there will be dependencies between interdisciplinary dependencies are there. So if you have to really come out with implementable activity sequences, this interdisciplinary collaboration have to start at this point itself. So if you are a planner or a project manager, that calls for tremendous amount of interdisciplinary coordination work. For activity sequencing, once we know the activity sequences, we may use activity sequence diagrams to show these activity sequences. There are two types of activity sequence diagram, that is the activity on arrow diagram and the activity on node diagram. Activity on arrow diagram, activities are represented on the arrows and connected at nodes. Whereas activity on node diagram, activities are within those boxes or nodes, and then they are connected by arrows. Within the activity on arrow diagram, we use dummy activity to show dependencies. A dummy activity doesn't consume any resources. And activity on arrow diagrams can show only finish to start dependencies. Hence, it is not that widely used. Activity on arrow diagrams are good for small projects with limited number of activities. Then activity on arrow will hold good. But activity on node diagram, that is the most widely used method. It can show all the four types of dependencies like finish to finish, start to start, and start to finish. And it is most widely used. And as discussed earlier, all these things calls for tremendous amount of intergroup coordination. Then see, here we get the first step is activity sequencing. Activity sequences happens within the disciplines. Then we have to merge these multiple disciplines sequences together. That is in step integrating activity sequences across multiple disciplines. And once we complete that, Then we have to we identify the critical path, uh, uh, which is the longest path in the network. And once we identify the critical path, as we all know, the activities on the critical path cannot slip. So we put all these activity sequences together, and we come out with the integrated project schedule. And generally, at this stage, the end date of the project may go beyond the required end date. So we have to optimize the schedule. We use multiple techniques like crashing. Crashing is by adding more resources into an activity, we can compress the duration of the activity. So that is crashing. And when we try to complete activities faster by putting more resources into it, the cost will be higher. We call it as the crash cost and the normal cost. That means if I put one resource into an activity and then try to complete it in 10 days, the total effort required is 10% days. At the same time, if I double the resources into two, I may be able to complete it in 6 days' time. Then the total effort becomes 12. So we do crashing and then we do fast tracking. That means trying to do things in parallel, which were originally scheduled sequentially. That is fast tracking and then resource leveling. And when we start allocating resources, based on the allocated resources, the activity durations will change. And sometimes we end up loading some resources too much, and some resources can be underloaded. So, through trial and error, we have to ensure that all resources are loaded to the tune of maybe 7 hours per day. We call that process for optimizing resource usage to the tune of 7 hours per day. We call it as resource leveling. And one aspect here, another aspect which is not there in the mind map is uh, application of leads and lags. A lag means maybe after pouring concrete, I have to wait for 8 days curing time. After that, only I can start the next activity. That is that is lag. Lag is waiting time. A lag always uh, stretches the schedule. So normal curing, it will take 8 days. But if I do steam curing, I can reduce the lag, but the cost can be more. So we may have to optimize the lags in order to achieve the desired end dates. And another opportunity is lags. Lead. Lead means parallelism. That means when I complete design 80%, I can start construction. So there is a 20% lead. A lead always compresses the schedule. And this is somehow connected with fast tracking also. Fast tracking is trying to do things in parallel which were originally scheduled sequentially. That is fast tracking. Whereas crashing is trying to compress the duration of the activities by putting in more resources into it. That is crashing. Then critical chain. Some of the resources can be very critical. If something happens to those resources during project execution, that will impact the critical path and the project duration. So we may have to always build up a plan B for those resources. That is the critical chain. So that is critical chain. So we may have to think through all these things to arrive at a final schedule. Then another key aspect is the near critical paths. Uh, Sometimes a project can have multiple critical paths. There can be more than one path which is the longest. So that means that project is slightly more complex to manage. Uh, at the same time, there could be a lot of paths which are not technically critical path because it has float. But if the float is very less, we call them as near critical paths. So technically for critical paths, float must be zero or it will be zero. But if I have another path whose float is just 3 days or 1 day, technically it is not critical path, but for all practical purposes, it is very close to critical path. We call them as near critical paths. And once we arrive at the schedule, then we have to do the schedule risk analysis. The most prominent one is the constructibility reviews. That means we created a great schedule. Is it implementable? Is it practical? Because the schedule should reflect the construction plan. The schedule should capture the path of construction or the construction plan. Otherwise, your schedule will be something else and the actual construction will happen in another way. So the constructability reviews by experts will give a lot of confidence on the schedule. And sometimes we have to do what if analysis. If I crash one activity to some extent, what is the cost and what is the benefit on the end date of the schedule? Or we said during estimation for one activity, we can come out with three estimates: optimistic, pessimistic, and the most likely. So if I try to adhere with the optimistic, what is the impact on cost as well as on the end date? Most likely, what is the impact on the cost and the uh, end date, etc. So this what if analysis of the schedule, we do it at the time of schedule optimization, and it continues throughout the execution because we may have to uh, revise the schedules constantly because of the dynamic nature. And sometimes Monte Carlo techniques are also applied uh, to which will support the what if analysis of the schedule. So with this much, we will have a schedule which is practical, which has a lot of confidence, and that is the time when we baseline the schedule. When we say baseline, we say schedule version 1.0. After that, any changes to that schedule, we may have to follow the change management process. And in the schedule management plan, we would have decided like who can update the schedule, who can revise the schedule, what is the process involved. So once the baseline is released, after that, everything will happen according to the schedule management plan. And throughout the project, we have to monitor and control the schedule. In the earned value management, we have the schedule performance index, schedule variance, and the schedule performance index. That is earned value by plan value. That is the schedule performance index, and the earned value minus plan value. That is the schedule variance. And then the schedule forecasting, everything we can do during the execution stage of the project. So we started with the scope definition part of it, And then we switch to at the WBS stage, that is the boundary. We develop the WBS, baseline the scope, then we come out with a schedule management plan, and then activity list, activity sequencing, uh, critical path, near critical path, critical chain of resources, schedule baseline. So we traverse through from high level scope at the charter level to the schedule baseline one. And I hope this video lesson gave you good value. Thank you very much.